Welcome to the online MOOC course on software engineering. This lecture will look into how we are going to translate from the requirements to design. So basically, the first phase of software engineering life cycle is requirement analysis, followed by the design phase. So here we are trying to translate the requirement models to design models. So here when you consider a set of requirements, so the requirements are going to be converted into a design model, and in between we have these many number of phases. So we start with analysis and abstraction. We'll check what exactly it is, and followed by the abstraction details, and we'll use a model transformation. There are some set of tools and other languages that are available, and then we'll go for a architectural mapping and then come up with a design model which suits the corresponding requirements. So the basic guiding principle for this model translation, that is to ensure the design fidelity to original requirements. So these are the guiding principle. The first one is traceability. So traceability is when there is a change in particular requirement. If not a change, a requirement, when it is going to influence another set of requirements, that will be identified using this traceability. So it is trying to establish clear links between the requirement analysis and the design artifacts, and it is going to be end to end. Okay, and the change with respect to this requirements and design visibility is, it will be identified end to end, so that the impact analysis could also be done properly. The second principle is abstraction consistency, where we try to ensure uniform levels of abstraction across the models to prevent the misinterpretation and gaps. Okay, so when we consider the models, the application of a model is not given any bias. We will be trying to provide uniform levels across all the models, so that there is no bias between the models. Stakeholders alignment. So this is again a very important aspect, because whenever you are going to have any business or technical need with respect to the project, the organization's thought should not hinder the stakeholder. So we have to make sure, or we have to validate whether whatever we are trying to do within the software development is aligned to the stakeholder. The fourth one is feasibility validation. We are trying to identify whether this change from the requirements to the design is feasible with respect to technical aspects. Okay, that is what has been given. So regularly we will try to assess the practical viability and the technical constraints of the proposed design models, and this will be done iteratively, so that you can do better the next time. Okay, so we adopt a cyclical approach of review and adjustment to enhance the model accuracy and quality. So these are the main guiding principles for model translation, to be specific from the requirements to design. So when we are trying to translate the requirements, we will consider this use case diagrams. So basically, what exactly is use case diagrams? You will be having set of use cases and actors, and the interconnection across the users and the use cases. Sometimes there will be interaction within the use cases also, where we have the extends relationship and includes relationship. So say for example, we will have a simple use case diagram. So assume there is a user. Okay, so the user is named as student. Okay, so user is going to borrow book. Okay, so if there is a functionality in say a library management system where a user who has to be a student can borrow book from the library. So, this is the requirement. So, that requirement is translated to a use case diagram through this. So, a user who is going to be a student can borrow book. Okay. The user, a student, can view available books. So, he can search for some books. Okay. So, being a student, he can search. So, likewise for the entire application, the entire set of requirements, you can draw a use case diagram. So, the use case diagram will have the set of actors who can interact to the system and a set of use cases which are nothing but the functionality of the corresponding system. I will give you an example for includes relationship. So, if you want to borrow a book, you have to be authenticated. Okay. So, only if you are a student of a particular college or a university, you will be allowed to borrow book, right. So, borrowing a book will include another functionality by default. So, this is going to be a include relationship. There will be an exclude relationship which is an optional entity. Okay. So, say for example, after borrowing a book, if you are going to generate a receipt generation could be done only after borrowing the book. So, that is related, but that is not included in borrowing. Okay. So, that could be an example for extends relationship. So, what we have understood here is using a use case diagram, we can visualize what are the requirements that are given by the stakeholders. So, having that in picture, we will go with the slide here. So, the requirement models, which is going to be the source, you can take the use case narratives. So, as I have given in the examples, say a student can borrow a book. So, that is one of the use case narrative. Okay. So, here the actor is going to be the student, the scenario is borrowing a book. So, likewise, all the set of requirements will be written as a use case narrative. Okay. Second is actor interaction. So, meaning the actor as a actor, how he is going to interact, whether he is say for example, while borrowing a book, to make sure he is authenticated, we have to check for the credentials. So, the user can give the user ID or password or any other barcode. So, that are going to be the interactions that is done by the actor. Okay. So, the actor interactions is going to be the functionalities or the actions that is going to be taken from the user side. Okay. And the set of responses, say for example, if he gives the ID and password, you may provide a response saying he is authenticated or an invalid user. Okay. So, this is going to be the system response that is also considered as your actor interactions. And the third one is use case steps. So, say for example, if your use case is going to be borrowing the books, what could be the series of steps? You have to check whether the book is available, and if it is available, you have to associate that book to this corresponding user ID, and you have to reduce the number of books available in the inventory. Okay. So, all these are going to be the steps within the use case. So, these are available in your requirements model, and that is available in your source. So, our idea is now to convert this requirement model to a design model, which is our target. Okay. So, how we are going to do this translation mapping? Okay. So, the use case narrative is going to become something such that it is converted to a design model. Okay. So, you can say it becomes or maps to or translate, and what it actually been done is what we have to consider. So, one is the component interfaces. Okay. So what we mean by a component? A component is going to be some functionality that is available in that corresponding software as a single component, which means that it can work standalone. So all those things are called as your component. Okay, so that includes interface definitions, method signatures. So a method could be analogously considered as a function. Okay, so that is going to be one component. Okay, second is service contracts. So say for example, if it is going to be a a defense system, the interaction to that corresponding system should be highly secure, correct? So the IO specs, which is the input output specification, has to be given much importance. Who can actually invoke that corresponding system? So everything has to be given much care. Okay, SLAs is again important. Service level agreements is called as your SLA. Service, sorry. Okay, so service level agreements are the states or are the information that you will consider your stakeholders to come up with. Okay, so say for example, if you are providing a request, the system should respond in a minimal time. So what exactly is a minimal time? How much seconds or how much millisecond is your SLA? Okay, so that is one example for SLA. Again, the availability, all those things comes under your service level agreement. So it is like what is going to be the level of service that we are going to provide. So that will be given as a agreement. So third one is the operational responsibilities. So say for example, it could be like what process we are going to do, what validation we have to do, something like that. So this actor interactions are something which a user is going to interact with the system, correct? So that could be mapped with the component interfaces. So where a component is available, a functionality is available, to which you can say who can interfere. Okay, so that interface could be identified from the actor interactions. Okay, and the say the scenario could be given from the method signature. What is actually the functionality? So everything, it is like component interface could be taken from user narratives or actor interactions or use case steps, and it will become a particular design model. Okay, so from the say actor interactions, you expect a response. So how much time gap can be between the user action and response comes under your SLA. Okay, so likewise, each and every source from the requirement model can used as a translation and to create your design model. So basically, that is with respect to our use case diagram. There are several other diagrams that could be used in your requirement models. So in this slide, we will try to understand how we can convert from entity diagrams. So entity relationship diagram is another diagram with which you can model your requirements. So here, if you consider, we have something called as a customer entity, order entity, product entity. There is a owner. Okay, so likewise, we have several entities, and the entities are communicating, or they have a relationship with some other entity. So say for example, a customer can order a product. Okay, so sometimes we have a relationship here, customer order for a product. Okay, and order has several products. So something like that. So the entity diagram is trying to say what all entities are participating in your project and how they are related with the other entities present inside your project. That's all. So from that, we are trying to do something called as domain analysis and abstraction. So, here first we will try to aggregate some things. So, all the entity cannot be modeled as one specific functionality. So, if necessary, we will group some of the entities to consider that as a function. Okay. So, that is why we call that as identifying the aggregates. Next, we will define the value objects. So, some immutable attributes will be identified and that will be defined as your value objects, and then we will extract the domain services. So, here basically the key operations and logic with respect to that project will be identified and extracted. So, this is trying to identify what exactly we are trying to actually focus on, what is the domain we are working on and the level of abstraction we need. The third step is actually model transformation and enrichment. So, here there are several models that are available with which we can convert this requirement analysis or requirement models to design models. So, basically what we do here is integrate all the business rules, apply the conditions and refine the relationship. So, what all relationship? The relationships that exist between these entities, and there will be some set of constraints. So, as I said, if you have if you want to borrow a book from the library, you have to be the member in the library and you should not have borrowed more than 3 books, just for an example. So, these two are going to be your conditions, being a student in that college, and if you have not borrowed more than 3 books is going to be the condition, and if that condition is true, you will proceed for giving that corresponding books. So, those are going to be your constraints. Business rules are with respect to the application level. Okay. So, once the model transformation and enrichment has been done, we try to create a domain model where all this the set of entities which are aggregated will be with respect to one module. So, this is module 1, say for example, and this is module 2. If you see, they are going to be like repeated. So, one module which is going to be an aggregate of set of entities, it will be having a customer and value objects. So, value objects are something like a small functionality with respect to that application. So, likewise you have several modules, okay, and these modules are put together to go for a domain service. Okay. So, this is actually the functionality of the project. So, the domain service will be having interaction to the modules, and sometimes the modules will also have the annotated rules. So, these are going to provide some instinct with respect to the design model. So, this is going to preserve the entire business logic that is available, and it ensures data integrity and also facilitates the evolution. So, next is the third diagram that we are going to use is state machines. So, we started with use case diagram, then we went on with ER, and now it is going to be state machines. So, what exactly is state machine? So, state translation diagram, it is another name for state machines, where you will try to visualize by giving some input the project, the software or any appliance that you have in your picture that will move from one state to another. Okay, and from that state, if you give some other input, it moves from that state to another. So, likewise you will move from one state to another on a corresponding input. Okay. So, that is actually your state machines. So, here you have this requirement state machine as your input. Okay, and we want to convert that to a object lifecycle management, which is actually your design. This is one design model, right. So, basically what we do in a state machine is that we have a set of states, we have a set of transition, and there are some guards. Okay. So, the states are converted into status fields for data persistence. So, what is persistent? Persistent is related to your storage. So, when you say the data is persistent, even though there is any issue with the software, the data will be available even after any fault. Okay. So, that is what we call it as persistent storage. Okay. The transitions, which are nothing but the methods, are considered as business logic, and the guards are nothing but your preconditions. So, when you want to move from one state to another, there will be a necessity for set of conditions to be true. So, that is considered as your preconditions. Okay. So, that could be taken as validation and control. Okay. So, taking this state machine into consideration, we are going to convert that as a object lifecycle management or your design models. Okay. So, consider here, so status fields, methods and the preconditions. So, these are the three things that we have to derive from this requirement state machine. So, you have status ID, current state and previous state. So, this is arrived from your state. Okay. So, when you have say, I will just say state 1, state 2. Okay. So, this is a state and this is another state. Okay. So, say for example, you have an ID. So, we will name this as ID 1 and ID 2. Okay. So, when you have status field, so this will be ID 2, current state is state 2 and the previous state is state 1. Okay. So, upon a condition or upon a input, you move from state 1 to state 2. Okay. So, the methods could be like, methods are done when you are in a particular state. Okay. So, within a particular state, maybe you can update status, or validate transaction, or execute some action. Okay. So, when you execute an action, maybe you can move from one state to another, state 3. Okay. So, these are going to be the methods. What are the preconditions? So, from before you move from one state to another, you have to check whether something is done or not. Okay. So, here they have given the example like checking the guard, checking the precondition, verifying the data and ensuring the dependencies. So, basically it is something like what are all the available states. So, that is available in your status fields, and within one state what functionality you can perform. So, that is given under your methods, and to move from one state to another, what are all going to be your preconditions or the set of conditions that has to be met. So, that is given under your post conditions. So, how this have been taken? The states are been considered as status fields, transitions are taken as methods and guards are taken as your preconditions. So, next is for linking requirements to design. For seamless implementation, we can also use this requirements traceability matrix. So, we will take this as an example. So, we have certain requirements. For simplicity, we have considered everything as functional requirements. So, functional requirement 1 is user login. Functional requirement 2 is data encryption. Functional requirement 3 is going to be report generation. Okay. So, on giving a particular requirement, you have to convert that to a design artifact, where designing is like a blueprint. You have not it is not coding. We are trying to identify how exactly it could be implemented in what all aspects. So more or less it is going to be a diagrammatic approach, or sometimes if it is a web application we can use this wireframes and all. Okay. So that is why we have a login screen wireframe. Wireframe is a blueprint of how the login screen should be. Okay. So since your requirement is login, user login, we have created a design artifact. So since this is a user interface, it is UI and a number has been given. Okay. So it is like user screen wireframe. So for data encryption, it is something related to your architectural things, right? So which encryption algorithm you are going to use, say firewall or whatever, okay, something related to your security, a non-functional thing. So here it is coming under your security module, okay. Third one is report generation. So report generation should be something with respect to the data that is available, okay. So when it is considered as a design artifact, it is taken as DB, okay. It is like reporting a schema that is available in your database, okay. So next is going to be your verification, which is coming under your testing. So assume that in between you have implemented and you have the code in hand, okay. So this wireframe has been implemented and you have a login screen, okay. So that login screen has to be checked with this test case TC101. So this TC might have a set of credentials, say a username and password, okay. So if that verification is done, if that test case has been passed, you can go for the stakeholder approval and make that as approved, okay. So who has approved? The role called as product owner, okay. So this security module is going to be with respect to code review first, and then you will have something like test case 101, okay. So this is having something called as pending and another one is approved. So code review is not yet done, but some level of other test case has been approved. So from this picture, what we can understand as a traceability is that the requirements have been mapped to design artifact, and the design artifact is mapped to a set of test cases, and that test cases is validated across the implementation, and you have we have an approval with respect to the stakeholders whether it is approved, pending or rejected, okay. So this is what we have understood from this slide, okay. So you can also check, there are several set of stakeholders, security architect. Why? Because this is a security module that you have considered, okay. So the security module has to be checked by a security architect only, okay. He will be having the domain knowledge, so it will be better. It is very important that you should have the domain knowledge to proceed, okay. And the business analyst sometimes is also doing the approval, because he can check whether the requirement is satisfied correctly or not. This slide, it says about the scenario based validation. So we have this end-to-end requirement stories, and it is going to be checked with respect to the design models, and this is going to help you in detecting the things early. If it goes far from our hand, it will detect it early, okay. So the same thing comes here also. You have a set of requirement stories. We normally call that as user stories, okay. So the user stories, they are in text, they are in diagrams, they are in their word of mouth also. So it is going to have end-to-end scenarios and use cases, meaning each and every requirement is given as a user stories, okay. And you can use some tools to simulate all the user stories and pick them for validation, okay. So when you do the simulation, you can come across these three things. One is missing interfaces. Second one is data gaps. Third one is behavioral mismatches. So what exactly is missing interface? So missing interface is something like you might have more than one module and there will be a miss in interfacing one or more modules which is actually necessary, you might have missed. Okay. So if you see here, we have a module 1 and there are some sub modules 101, 102 and 103 and this is expected, but you don't have that in the reality. Okay. So the interface across the modules which is actually necessary is missing. Okay. So that could be identified through this simulation. Second is data gaps. So sometimes the data that is available will not be taken correctly. Okay. So that is also that could also be verified with this scenario based validation. Next is behavioral mismatches. So you expect in a different manner, but the software is behaving in a different sense. So that could also be taken care. So when all these things are detected early, that could be validated, and obviously we have to redo that with respect to design and implementation. And once everything is correctly validated for pass, you can go for converting that to your design models. Okay. So this is going to give you a validated or refined system architecture with respect to design. So there are some available models in the new scenario. We have something like QVT, which is query value transformation, and ATL transformation languages. So these are the languages that are used as transformation. So basically we are trying to move from one model to another. Here it is requirements to design. Something like that we can move from one model to another by using these kind of transformation languages that are available commercially, with which you can move from source to target. So continuous integration for requirements to design synchronization. So here there are several automated pipelines are available for this versioning, which we will see here. So versioned model repositories. Okay. So nowadays most of the people are using Git based storage, so which is going to be a online available public software. So where you can upload the code and you can do all the versioning. So this also creates traceability links and branching strategies. You can fork them, you can commit, everything is available in this versioned model repositories. Next is it is very difficult at times when your project is very enormous. Okay, for each and every change you cannot add all the modules to the repository. Okay, so at that time we can go for diff detection, meaning only if there is a difference in that corresponding module and if it is going to have much higher impact, then only you will upload that. Okay, so it does something called as automatic change detection. It does automatic change detection and it creates visual diff reports. So it will create the difference with respect to the modules. Okay, so this is also available, and we have something called as pull request reviews for design. So this can also be taken for this automated pipelines. As an example, you can consider this. We are trying to transform the requirements to a microservice design. Okay, so here some similar to the prior slides, we have some user stories, business requirements and data requirements, and this is going to be converted to another design which is called as microservice architecture mapping. So the user stories, all these things are converted to REST endpoints. So REST is an API with which you can communicate, or with which you can access the service. Okay, so get, checkout, post, payment, everything could be done, and the service logic that could be accessed, say for example it could be order processing or validation, and you can also have the database things. So the data requirements is nothing but your database, so that could be also converted into microservice design using this schema definitions. Okay, so basically it is trying to move from one model to another. So here the example is microservice design. So through some case studies and other available study, we can identify that there is a 40% decrease in the downstream defects when we use this translation models, and since it is automated, we could deliver it at a very faster pace. It is almost increasing to 25%, and the requirement coverage in design test has been increased to 90%, which is very high when compared to the earlier traditional models. So this is also having some set of success factors and pitfalls. So the success factors is that when you have clear idea of how to transform from requirements to design, it is good, but sometimes it is overly abstracted, okay, which will hinder the performance. Okay, so you should need a clear model transformation rule. So this is very, very important, and the cross functional collaboration is expected, and there is a iterative validation cycle. So this is not a one step process, you do it again and again, and at the nth step maybe you can create a better design model, and it is robust tooling integration. So it has a very good integration when it is attached. The cons, the pitfalls that are encountered is that it is having very complex abstraction. Okay, and since it is costly, you will not have that much knowledgeable stakeholders to get all the details. Okay, and the architectural constraints, if it is ignored, and again it is going to be a issue, and there is a lack of formal training. So once if you have everything correct only, the output is going to be good, otherwise it is going to be a little bit difficult. Okay, so mostly if the abstraction is very complex, and the training is also very much necessary. So here another simple example of how you can move forward. This is you have a lightweight traceability. So you have the foundation link, the traceability requirements to initial design sketches and concepts, followed by aligning to a domain driven model. You can go for pilot automation tools, and you can go for review. Okay, so this is going to be the roadmap. You move from traceability, go to domain driven modeling, use some pilot automation tools, and review the whatever we have created. So this slide is trying to provide you a roadmap from the traceability to the review gates. So traceability, we have understood that from the requirements till how we are going to complete, everything is available. So we start with the foundation link and trace the requirements to initial design sketches and concepts. Through that we can have high visibility and basic linking, followed by domain driven modeling. So here all the modules are aligned with the business domain. We are trying to introduce bounded context and ubiquitous languages. So this is going to focus on strategic alignment and clarity. The third step is going to be pilot automation tools. Usage of these tools is actually the main important phase where the translation happens, and this is going to generate the design artifacts from the structured models. So, this is the main activity, and the last one is, once you have done, we have to review it. So, by using the formal checkpoints, we can go forward and go for the sprint cycles and other retrospectives. Okay. So, this is actually the translation of requirements model to design models. Thank you.